Good evening, dear students of BTech third semester EX department, SIIT College. Today, I'm sharing you, or I can say I'm explaining you my YouTube video lecture number 10 on the topic Wheatstone Bridge, and now I'm sharing my screen to you. So, we will study here regarding Wheatstone Bridge, its working principle, its applications, and all. So, we'll move to the next slide. This is Wheatstone Bridge. So as we know, in instrumentation, we have to measure several quantities here. So Wheatstone bridge, also known as resistance bridge, calculates the unknown resistance by balancing the two legs of the bridge circuit. One leg includes the component of unknown resistance. The Wheatstone bridge circuit comprises two known resistors, one unknown resistor, and one variable resistor. That means there are four types of resistors: two known resistors, one unknown resistor, and one variable resistor connected in the form of bridge. That's why it is known as Wheatstone bridge. This bridge is very reliable as it gives accurate measurements. Now we'll move to next slide. Construction of Wheatstone bridge. A Wheatstone bridge circuit consists of four arms. As I already told you, it will have four kinds of resistance in its four arms. So Wheatstone bridge circuit consists of four arms, of which two arms consist of known resistance, while the other two arms consist of unknown resistance and a variable resistance. This circuit also consists of a galvanometer, which will be indicating device, and an electromotive force source. That means EMF also there. This EMF source is attached between points A and B, while the galvanometer is connected between points C and D. The current that flows through the galvanometer depends on its potential difference. Now we will see how it happen. Principle. The Wheatstone bridge principle works on the that means this bridge works on the principle of null detection, or we can say null deflection. That means I mean to say we have used here galvanometer device which will show you null deflection. So this bridge works on the principle of null deflection. That is, the ratio of their resistance is equal and no current flows through the circuit. That means if resistance ratio is equal, there will be no current flows through the galvanometer. Under normal conditions, the bridge is in unbalanced condition where current flows through the galvanometer. So this bridge is said to be balanced when no current flows through the galvanometer. This condition can be achieved by adjusting the known resistance and a variable resistance. That means already mentioned there will be four kinds of resistance. Two will be unknown, then known resistance and variable resistance. So this balanced condition will be achieved by known resistance and variable resistance. Look at this figure. It is having four arms P, Q, R, and S. So this S will be your what? This will be your variable arm, and these are the ratio arms P and Q, and this R is your unknown resistance. And this is battery E, which is connected between point here A and C. So how? We will move to next slide. Derivation of this unknown resistance. How can we find out unknown resistance? So in this figure, you have seen this is EMF source is given here. So we have taken some current directions, I1 and I3 in these two ratio arms P and Q, and I2 and I4 in these two arms R and S. So current enters the galvanometer and divides into two equal magnitudes current as I1, I2. The following condition exists when the current flows through a galvanometer. When the current flows through a galvanometer is zero. That means this I1P equals to I2R. This is the condition. So that current through this galvanometer is zero. The current in the bridge in balanced condition are expressed as follows. I1 equals to I3 equals to E divided by P plus Q. E divided by P plus Q. And I2 equals to I4. That means E divided by R plus S. Here is the EMF of battery. by substituting the value of I1 and I2 in equation number 1. In this equation number 1, we will put this I1 and I2 values from here. So we will get PE upon P plus Q equals to RE upon R plus S. Now we will cross multiply it. So P upon P plus Q equals to R upon R plus S. And now P R plus S equals to R P plus Q. And by by solving this bracket, PR plus PS equals to RP plus RQ. So here RP and PR both are given in left hand side, right hand side, we will cancel out. So we will have PS equals to RQ. So here in this equation number 2, we can find out R, which will be equals to P divided by Q into S. So equation number 2 shows the balance condition of the bridge, while the equation 3 determines the value of unknown resistance. In this figure, R is unknown resistance, S is the standard resistance of the bridge, and P and Q are the ratio arm of the bridge. So in this way, we can find out this unknown resistance R. We will move to the last slide. Hence, we can say unknown resistance R will be equals to P upon Q into S, where R is unknown resistance, S is the standard resistance of the bridge, and P and Q is the ratio arm of the bridge. Now its application. Wheatstone bridge is used for the precise measurement of low resistance. Wheatstone bridge and an operation amplifier are used to measure physical parameters such as temperature, light, and strength. These are the further application of this bridge. Quantities such as impedance, inductance, and capacitance can be measured using variations on the Wheatstone bridge. But we are primarily focusing, as per your semester, on the measurement of low resistance, which will be done by Wheatstone bridge. Thank you very much. Hope you will understand this video. Thank you for your support, and please watch it. Thank you.